Hello, and welcome back to the Cosmos Sleep Channel.
The first quiet glow after the Big Bang. In the earliest moments of the universe, before stars, galaxies, or planets existed, space was filled with a soft, expanding warmth. This glow emerged as the dense, hot cosmos gradually cooled, allowing light to travel freely for the first time. Though faint today, this ancient radiation still surrounds everything, forming a peaceful background that stretches across the entire sky. It drifts with remarkable uniformity, carrying subtle variations that reveal how the universe slowly shaped itself. This gentle glow is often described as a cosmic whisper, a lingering reminder of the universe's first breath. Its presence creates a soothing backdrop to all cosmic activity, offering a calm window into a time long before structure or motion existed. The silent spreading of the cosmic web. As the universe expanded, matter gathered into a vast structure known as the cosmic web. This formation grew slowly over billions of years, shaped by gravity's soft pull. The web consists of long filaments, broad sheets, and deep voids that extend across unimaginable distances. Each part forms without noise or disruption, evolving in smooth, continuous patterns. Light from distant galaxies travels through this network, revealing its delicate architecture. The cosmic web guides the flow of gas and the formation of stars, acting as the universe's quiet framework. Its gentle design shows how immense structures can arise through patient, unhurried forces that shape everything with calm precision. The peaceful cooling of the early universe. After the universe first expanded, temperatures dropped steadily in a long, tranquil process. This cooling allowed particles to combine into atoms, creating an environment where light could finally move freely. The transformation unfolded gradually, as if the universe were settling into a restful state after an energetic beginning. With time, this cooling shaped the conditions for stars and galaxies to form. The change did not occur in sudden bursts, but in smooth transitions that spread across the cosmos. This gentle cooling phase represents one of the universe's most serene periods, where complexity emerged from calm, consistent decline in temperature. The soft gathering of hydrogen clouds. Hydrogen, the universe's most abundant element, drifted through space in enormous clouds that stretched across great distances. These clouds moved in slow currents, influenced by gravity and the expanding fabric of space. Over time, slight differences in density caused them to gather into regions where temperatures dropped even further. Their stillness held enormous potential, storing the material needed for the first stars to ignite. The movement of these hydrogen clouds reflects a peaceful process where simplicity gives rise to structure. Their gentle consolidation remains one of the universe's earliest and most soothing mysteries. The calm birth of the first cosmic structures. Before stars and galaxies took shape, the universe developed small, dense areas that acted as seeds for future structures. These regions grew silently, collecting gas and matter through steady gravitational attraction. They formed the blueprint for everything that would follow, from clusters of galaxies to solar systems. Their development required no sudden events, only continuous gathering over millions of years. These early structures formed a quiet foundation for the universe's evolution, showing how complexity can emerge from gentle beginnings. Their presence reveals the patient nature of cosmic growth and the calm pathways that lead to the formation of stars and planets. The silent ignition of the first stars. The earliest stars ignited deep within dense clouds of hydrogen, shining softly into the surrounding darkness. Their birth was a slow process, shaped by increasing pressure and temperature inside collapsing gas pockets. When they finally lit, they brought the first true light to the universe. These stars burned with an intensity unlike any that followed, yet their glow spread through space in gentle waves, illuminating the darkness with a calm radiance. They forged the first heavy elements, providing the ingredients for future planets and life. Their quiet ignition marked a serene turning point in the universe's evolution. The soft formation of ancient star clusters. As more stars formed, they gathered into clusters bound by gravity. These collections drifted gently through early galaxies, glowing with a peaceful brilliance. The stars within them moved in synchronized orbits, creating a calm, unified motion. Over time, these clusters became long-lasting structures that survived cosmic collisions and transformations. Their stability reflects the balanced forces holding them together. Ancient clusters still drift through galaxies today, carrying the serene light of stars born in the universe's earliest moments. Their presence adds quiet beauty to the cosmic landscape, representing harmony across immense spans of time. The tranquil expansion of early galaxies. Early galaxies formed from slowly rotating clouds of gas that settled into graceful shapes. Their rotation smoothed out irregularities, creating calm, spiral-like motions. Over millions of years, stars arranged themselves into stable orbits, forming the first organized galactic structures. These galaxies glowed with soft, newly formed starlight, drifting through space with gentle momentum. Their expansion reflected the universe's broader evolution, taking place in peaceful stages. Early galaxies were smaller and more delicate than those of today, displaying an understated elegance that emerged from slow, steady development rather than dramatic events. The soft light of forming nebulae. Nebulae appeared as gas clouds became illuminated by young stars, producing gentle colors and soft glows. These clouds expanded quietly, shaped by radiation and faint pressure from surrounding space. Their structures evolved gracefully, forming intricate patterns over long stretches of time. Nebulae create environments where new stars are born, adding calm cycles of creation to the galaxy. Their light reflects off dust and gas, generating smooth gradients and subtle hues. The beauty of these nebulae lies in their tranquility as they drift and transform without violence, offering peaceful regions of cosmic creativity. The gentle drift of cosmic dust. Tiny particles of dust float between stars, moving with delicate motion through interstellar space. These grains form from aging stars and spread quietly into surrounding regions. Over time, they gather into dense patches where planets and comets may eventually develop. Dust absorbs and scatters starlight, creating serene textures within nebulae and galaxies. Each particle drifts with almost no resistance, guided only by soft forces of gravity and radiation. This slow movement helps shape the structure of cosmic environments, showing how even the smallest components of the universe contribute to its gentle evolution. The balanced motion of early planetary systems. As stars settled into mature phases, disks of dust and gas surrounded them. These disks rotated calmly, forming circular patterns that encouraged the creation of planets. Over time, small particles collided softly, gathering into larger bodies. These early planetary systems developed with remarkable order, guided by gravity's steady influence. their emerging orbits aligned into harmonized paths that remained stable for millions of years. This period of planetary formation was not chaotic, but deliberate and calm, reflecting the natural balance found throughout the cosmos. The quiet stabilization of star orbits within forming galaxies. Stars gradually settled into predictable orbits influenced by gravity and the distribution of surrounding mass. This stabilization created long-lasting patterns that kept stars moving smoothly through their environments. These orbits prevented collisions and maintained order within the galaxy's structure. Over time, the balanced motion of stars produced a calm rhythm that defined the spiral arms and overall shape of galaxies. This quiet orchestration represents one of the universe's most elegant processes, demonstrating how harmony can emerge from millions of individual motions, aligned by natural forces. The silent merging of small protogalaxies. Early galaxies often formed from smaller protogalaxies, merging quietly over long spans of time. These mergers unfolded gently, guided by gravity's slow pull rather than sudden collisions. Stars passed by each other without impact, allowing the galaxies to blend smoothly. This process helped create larger, more structured galaxies that continued to evolve in tranquil stages. The merging motion shaped the distribution of stars and dark matter, forming new patterns that would persist for billions of years. The calm nature of these early mergers reveals the universe's ability to integrate complexity without turbulence. The deep stillness of vast cosmic voids. Cosmic voids are enormous regions with few galaxies, stretching across hundreds of millions of light years. These areas remain incredibly quiet, with little motion or light. Matter is sparse, creating a sense of vast stillness that contrasts with the busier regions of the universe. Within these voids, only a handful of galaxies drift through deep darkness, moving slowly under the influence of distant structures. Their emptiness highlights the universe's balance between activity and calm. These silent spaces play a major role in shaping the cosmic web, offering peaceful expanses where gravity acts with subtle and graceful influence. The gentle rise of spiral arm patterns. Spiral arms formed gradually as waves of density traveled through rotating galaxies, guiding stars and gas into elegant curves. These patterns emerged without force or chaos, taking shape through the natural motion of matter responding to gravity. The arms rotate slowly, maintaining their form while individual stars move in and out of the pattern. Their presence creates regions of soft star formation, adding calm brightness to the galaxy's structure. Spiral arms represent one of the universe's most graceful designs, formed over long stretches of time through smooth, balanced dynamics. The silent drift of rogue planets travel through the galaxy without the warmth or guidance of a parent star, drifting in deep darkness with soft, unhurried motion. These worlds may carry frozen atmospheres or hidden oceans sealed beneath thick layers of ice, warmed only by the faint heat of their interiors. Their isolation creates an environment untouched by radiation or stellar winds, allowing them to move peacefully through interstellar space. Some may pass near stars and briefly shine as their surfaces reflect distant light before fading again into the quiet. Their journeys stretch across billions of years, shaped only by gravity's gentle influence. Rogue planets remind us that not all cosmic paths require a destination. Some simply continue forward in calm, endless motion. The deep echo of black hole. Mergers when two black holes spiral toward one another. Their final union creates ripples in spacetime that travel softly across the universe. These gravitational waves pass through matter without disturbance, stretching and compressing space in subtle, rhythmic pulses. Though the event is immense, its signal arrives as a calm whisper, detectable only by sensitive instruments. The black holes merge into a single, larger one that quickly settles into stillness, releasing any remaining vibrations into the cosmic background. This quiet aftermath highlights the universe's ability to absorb powerful events and transform them into gentle patterns. The serene fading of these waves reflects the balance between extreme forces and the tranquility that follows. The soft veil of the interstellar medium. The interstellar medium is a tranquil ocean of gas and dust that fills the space between stars. Though incredibly thin, it provides the material that forms new galaxies, nebulae, and planets. Its particles drift with delicate currents, shaped by ancient supernova explosions, magnetic fields, and gentle radiation. Some regions glow faintly as starlight scatters across fine grains of dust, while others remain cool and dark. Over time, clouds within the medium gather into denser pockets where stars slowly take shape. This subtle, patient movement reveals the universe's ability to nurture creation through calm, unseen processes that unfold across millions of years. The hidden calm of neutrino streams. Neutrinos pass through matter with almost no interaction, moving effortlessly through stars, planets, and galaxies. Trillions of them drift through every person each second. Yet their presence remains undetectable without specialized equipment. These particles originate from nuclear reactions inside stars and from ancient events near the beginning of the universe. Their journey is gentle and uninterrupted, continuing across billions of light years without slowing or scattering. Neutrino streams form a quiet background flow that connects distant regions of space. Their soft persistence reveals a layer of the cosmos that functions independently of light, heat, or sound, highlighting the universe's most peaceful form of motion, the quiet breath of white dwarfs. White dwarfs are the calm remnants of stars that once burned brightly. After releasing their outer layers, these dense cores cool slowly over billions of years, glowing with a soft, fading light. Their surfaces remain still and stable, lacking the turbulence of larger stars. As they cool, their brightness diminishes in smooth, predictable steps, until eventually they become dark, silent remnants, known as black dwarfs. This gradual transformation reflects a peaceful ending to a star's long life cycle. White dwarfs drift through galaxies like warm embers cooling in the night, offering a serene reminder of stellar evolution's quiet final stage. The subtle motion of galactic tides form when nearby galaxies gently pull on one another, stretching their shapes over millions of years. These interactions create long streams of stars and gas that drift into space with slow, graceful motion. Rather than violent collisions, most galactic encounters unfold with patience, allowing structures to blend and rearrange without disruption. As galaxies pass, their tidal forces encourage new star formation and alter the paths of existing clusters. The resulting changes occur so gradually that they resemble soft waves spreading across a cosmic ocean. Galactic tides demonstrate how vast structures can influence each other with elegance and balance. The stillness within cosmic voids. Cosmic voids are enormous, nearly empty regions that span hundreds of millions of light years. Inside these expanses, matter is sparse, light is faint, and motion unfolds slowly. A few isolated galaxies drift quietly through the darkness, shaped only by distant gravitational influences. These voids provide a peaceful contrast to dense clusters and bright filaments, offering silent chambers within the cosmic web. Their serene stillness creates space for large-scale structures to form around them, guiding the distribution of galaxies. Cosmic voids reveal the calming balance between emptiness and creation that defines the universe's largest patterns. The gentle pulse of neutron. Star glitches. Neutron stars rotate with extraordinary precision, yet occasionally they experience tiny adjustments in their spin, known as glitches. These events arise from subtle shifts in the star's dense interior or crust. Though powerful in nature, the resulting signals spread through space as soft pulses, carrying information about the star's deep structure. After each glitch, the neutron star returns to its steady rhythm, spinning with renewed consistency. These gentle variations allow scientists to study the hidden layers of these remarkable objects. The calm return to equilibrium highlights the stability and balance that define neutron stars despite their extreme conditions. The slow bloom of planetary nebulae. Planetary nebulae form when aging stars release their outer layers into space, creating glowing shells of gas that expand with smooth, gradual motion. Their colors arise from starlight, illuminating the drifting material, producing soft blues, greens, and reds. The nebula's shape evolves slowly, guided by gentle winds and magnetic fields. At its center, the remaining core cools quietly, while the surrounding gas disperses over tens of thousands of years. The transformation resembles a delicate, cosmic flower unfolding in the dark. Planetary nebulae stand as peaceful expressions of stellar change, offering beauty during a tranquil final stage of a star's life. The tranquil drift of tidal dwarf galaxies. Tidal dwarf galaxies form from streams of gas and stars pulled away during galactic interactions. Their birth is gentle, occurring as the material slowly condenses into small, stable structures. These galaxies drift alongside their parent systems, like calm companions, carrying recycled starlight within simple, harmonious forms. Their evolution is slow and steady, lacking the turbulence found in larger galaxies. Over time, tidal dwarf galaxies become peaceful contributors to the cosmic landscape, reflecting the universe's ability to create new structures from the quiet aftermath of older ones. Their presence demonstrates how beauty can rise from the softest motions of gravity. The dim whispers of fossil galaxy remnants. Some galaxies contain ancient stellar populations left behind by mergers that occurred billions of years ago. These fossil remnants glow softly with the light of old stars, drifting in stable orbits that reveal their long history. Their chemical compositions preserve clues about early cosmic events, functioning as time capsules within modern galaxies. They move gently through their environments, undisturbed by recent activity. Fossil remnants demonstrate how the universe carries memory within its structures, maintaining calm, ancient patterns long after their origins have faded. Their persistent light adds depth and tranquility to galactic evolution. The gentle flow of dark matter. Halos. Dark matter halos form the invisible framework surrounding galaxies, providing the gravitational support that shapes their rotation and structure. Though undetectable by sight, these halos influence stars with a consistent and quiet pull that extends across vast distances. Their presence holds galaxies together, preventing them from drifting apart as they spin. The motion within a dark matter halo is smooth and stable, affecting matter without pressure or sound. This hidden architecture reveals how much of the universe relies on forces that act with subtlety and calm strength, guiding galaxies with effortless balance. The smooth turning of galactic bars. In many spiral galaxies, including our own, a central bar of stars rotates through the core like a slow, deliberate wheel. This structure gently directs gas toward the center, encouraging steady star formation. The bar's rotation is gradual, taking hundreds of millions of years to complete a single turn. Stars within it follow elongated orbits that create a harmonious flow through the galaxy's heart. This motion adds stability to the surrounding spiral arms and shapes the galaxy's long-term evolution. The bar's quiet presence demonstrates the universe's capacity for order and graceful motion on grand scales. The quiet rise of supermassive black holes. Supermassive black holes grow over billions of years by gathering gas, dust, and sometimes stars from their surroundings. This growth often occurs through slow, steady accretion rather than dramatic bursts. Gas spirals inward with calm, predictable motion, releasing faint radiation before crossing the event horizon. During these quiet periods, the black hole influences the galaxy mainly through its gravitational presence, stabilizing the central region. These long intervals of stillness illustrate how even the most powerful cosmic objects can exist in balanced, peaceful states, shaping their environments with subtle guidance rather than constant activity. The soft geometry of cosmic filaments. Cosmic filaments create the universe's largest known structures, stretching like gentle threads between clusters of galaxies. These formations arise from the slow flow of matter along gravity's natural pathways. Gas, dark matter, and distant galaxies align along these filaments, forming elegant lines that extend for hundreds of millions of light years. Their growth is patient and unhurried, shaping the cosmic landscape with smooth precision. Matter travels along them like a quiet current, feeding clusters and guiding the formation of new structures. These filaments reveal the universe's innate preference for calm, organized patterns across the greatest possible scales. The calm alignment of galaxy superclusters. Galaxy superclusters are enormous groupings of smaller clusters and galaxies that extend across hundreds of millions of light years. Their formation results from the slow, steady pull of gravity acting over vast periods of time. These immense structures move gently along cosmic filaments, held together by delicate gravitational connections that create balanced, harmonious shapes. Within a supercluster, galaxies drift in quiet orbits, shaping a serene environment where motion unfolds so gradually that it becomes almost imperceptible. Their collective presence reveals a soft architecture woven into the fabric of the universe. Superclusters demonstrate how even the most massive arrangements can arise through patient, unhurried processes, creating peaceful landmarks that anchor the grand design of the cosmos. The silent descent into black holes. Black hole accretion disks. Matter falling toward a black hole, collects in a glowing disk that rotates with smooth precision. Though the inward journey is powerful, it unfolds gradually, shaped by the delicate balance of gravity, rotation, and magnetic fields. Gas within the disk heats and glows softly as it spirals inward, forming a calm, continuous flow. Each layer moves at its own speed, creating a natural gradient of temperature and light. The inner regions draw matter closer with quiet certainty, while the outer parts drift slowly in wide arcs. This process reveals a gentle side to black hole evolution, where motion remains organized and rhythmic even near the universe's most extreme objects. The soft persistence of cosmic background neutrinos. Cosmic background neutrinos are remnants from the universe's earliest moments, drifting through space since long before atoms formed. These particles travel with incredible ease, barely interacting with matter as they move across the cosmos. Their motion is constant and gentle, forming a quiet background flow that permeates every region of space. Though nearly impossible to detect, they provide subtle clues about the young universe and its soft transitions into order. Their continuous presence reflects a calm endurance, demonstrating how energy can persist for billions of years without disturbance. Cosmic background neutrinos embody the universe's most delicate form of motion. The gentle renewal of stellar winds stars release streams of particles known as stellar winds, which drift outward in smooth, steady waves. These winds shape surrounding environments by clearing space, distributing elements, and influencing the formation of new stars. The flow is typically calm and predictable, creating expanding bubbles that move quietly through interstellar regions. Over time, stellar winds blend with broader currents in the galaxy, adding subtle energy to the interstellar medium. Their long-term influence reflects a peaceful recycling process where stars share their materials with the cosmos in continuous soft breaths. Stellar winds reveal a gentle connection between stars and their surroundings. The tranquil weight of dark energy. Dark energy influences the expansion of the universe with a steady, pervasive pressure that pushes galaxies apart at an accelerating pace. Its effect is uniform and silent, acting across the entire cosmos without turbulence or impact. This mysterious form of energy forms a calm, invisible backdrop that guides the universe's long-term evolution. Though its nature remains unknown, its influence is unmistakable. Galaxies drift farther from one another with smooth, unbroken momentum. Dark energy provides a quiet counterpoint to gravity, balancing cosmic forces with softness rather than force. It shapes the universe's destiny through the simplest and most tranquil form of influence. The subtle rotation of Saturn's hexagon. At Saturn's north pole, lies a remarkable hexagonal pattern formed by a persistent atmospheric current. This vast structure rotates with surprising stability, maintaining its shape through balanced motion in the planet's atmosphere. The pattern's edges remain sharp yet gentle, revealing a harmonious flow of winds that circle the pole in smooth alignment. Despite its size, the hexagon evolves slowly, shifting in soft gradients over years and decades. Its presence demonstrates the quiet precision of fluid dynamics on a planetary scale, creating a serene geometric formation that moves with natural elegance. The quiet drift of interstellar comet visitors. Occasionally, comets from outside the solar system pass through, traveling along paths shaped by distant stars. These visitors glide through space with gentle momentum, untouched by the gravitational patterns that guide native comets. Their motion is smooth and uninterrupted, carrying dust, ice, and minerals that formed in other star systems. As they pass near the sun, they release soft, glowing tails that create brief, delicate displays before returning to the darkness between stars. Their fleeting presence offers a peaceful reminder of the quiet connections that link distant regions of the galaxy. The soft dance of exoplanets in resonant orbits. Some planetary systems contain exoplanets that move in resonant orbits, where their periods align in simple ratios, such as 2:1 or 3:2. This arrangement creates a stable, rhythmic pattern that remains steady for millions of years. The planets influence each other gently through gravity, maintaining harmony within their shared system. Their motion resembles a quiet cosmic dance, with each world following a path that complements the others. Resonant orbits reveal how planets can coexist in elegant balance, forming stable and calming patterns that contribute to the overall serenity of their star systems. The calm circulation of hot Jupiter atmospheres. Hot Jupiters are gas giants that orbit very close to their stars, creating atmospheric patterns shaped by intense but stable energy. Their winds move with steady flow, redistributing heat across the planet in slow, continuous cycles. These atmospheric motions produce soft gradients of color and temperature, forming bands, swirls, and drifting structures that evolve without abrupt changes. Despite their proximity to strong radiation, the planets maintain a quiet equilibrium through the persistent circulation of gases. Their atmospheres demonstrate the universe's ability to create balance even under extreme conditions, revealing calm dynamics within hot, glowing worlds. The silent glow of ultra-diffuse galaxies. Ultra-diffuse galaxies contain far fewer stars than typical galaxies, spreading them across large areas that create a faint, ghostly appearance. Their light is soft and dim, forming gentle patterns that drift through space with minimal disturbance. These galaxies rotate slowly, held together by dark matter halos that support their fragile structures. Their sparse nature gives them a quiet beauty, as if they float on the edge of visibility. Ultra-diffuse galaxies remind us that not all cosmic structures require brightness or complexity. Some exist as peaceful shadows within the universe's grand design. The gentle formation of starless cores. Starless cores are dense pockets of gas within molecular clouds where conditions are slowly becoming right for star formation. These regions remain dark and cool, with motions so subtle that they appear almost completely still. Over time, gravity draws the material inward, forming a quiet concentration of matter that may eventually ignite into a new star. The process is slow, measured in millions of years, and unfolds without turbulence. Starless cores represent the soft beginning of stellar evolution, demonstrating how the universe prepares for creation through calm, gradual steps. The soft unfolding of protoplanetary disks. Around young stars, disks of dust and gas spread outward in circular layers, forming the raw material for planets. These disks rotate smoothly, creating lanes and gaps shaped by emerging worlds. Their motion is serene, guided by temperature, gravity, and magnetic fields that act gently across the structure. As planets grow within them, the disks evolve with quiet precision, slowly organizing themselves into stable arrangements. The process provides a calm foundation for planetary systems, revealing the universe's ability to shape order from delicate patterns of drifting matter. The tranquil descent of solar prominences. Solar prominences are vast loops of glowing plasma that rise above the sun's surface before gradually falling back under gravity's steady pull. Their motion is smooth and deliberate, forming graceful arcs that last for hours or days. These structures glow with soft warmth, drifting through the solar atmosphere with gentle curves. Even though the sun is a turbulent environment, prominences often behave with surprising stability, maintaining their form as they move. Their slow descent reveals a peaceful side of solar activity, showing how even energetic processes can unfold with elegant calm. The quiet drift of interstellar comet visitors. Occasionally, comets from outside the solar system pass through, traveling along paths shaped by distant stars. These visitors glide through space with gentle momentum, untouched by the gravitational patterns that guide native comets. Their motion is smooth and uninterrupted, carrying dust, ice, and minerals that formed in other star systems. As they pass near the sun, they release soft, glowing tails that create brief, delicate displays before returning to the darkness between stars. Their fleeting presence offers a peaceful reminder of the quiet connections that link distant regions of the galaxy. The soft dance of exoplanets in resonant orbits. Some planetary systems contain exoplanets that move in resonant orbits, where their periods align in simple ratios, such as 2:1 or 3:2. This arrangement creates a stable, rhythmic pattern that remains steady for millions of years. The planets influence each other gently through gravity, maintaining harmony within their shared system. Their motion resembles a quiet cosmic dance, with each world following a path that complements the others. Resonant orbits reveal how planets can coexist in elegant balance, forming stable and calming patterns that contribute to the overall serenity of their star systems. The calm circulation of hot Jupiter atmospheres. Hot Jupiters are gas giants that orbit very close to their stars, creating atmospheric patterns shaped by intense but stable energy. Their winds move with steady flow, redistributing heat across the planet in slow, continuous cycles. These atmospheric motions produce soft gradients of color and temperature, forming bands, swirls, and drifting structures that evolve without abrupt changes. Despite their proximity to strong radiation, the planets maintain a quiet equilibrium through the persistent circulation of gases. Their atmospheres demonstrate the universe's ability to create balance even under extreme conditions, revealing calm dynamics within hot, glowing worlds. The silent glow of ultra-diffuse galaxies. Ultra-diffuse galaxies contain far fewer stars than typical galaxies, spreading them across large areas that create a faint, ghostly appearance. Their light is soft and dim, forming gentle patterns that drift through space with minimal disturbance. These galaxies rotate slowly, held together by dark matter halos that support their fragile structures. Their sparse nature gives them a quiet beauty, as if they float on the edge of visibility. Ultra-diffuse galaxies remind us that not all cosmic structures require brightness or complexity. Some exist as peaceful shadows within the universe's grand design. The gentle formation of starless cores. Starless cores are dense pockets of gas within molecular clouds where conditions are slowly becoming right for star formation. These regions remain dark and cool, with motions so subtle that they appear almost completely still. Over time, gravity draws the material inward, forming a quiet concentration of matter that may eventually ignite into a new star. The process is slow, measured in millions of years, and unfolds without turbulence. Starless cores represent the soft beginning of stellar evolution, demonstrating how the universe prepares for creation through calm, gradual steps. The soft unfolding of protoplanetary disks. Around young stars, disks of dust and gas spread outward in circular layers forming the raw material for planets. These disks rotate smoothly, creating lanes and gaps shaped by emerging worlds. Their motion is serene, guided by temperature, gravity, and magnetic fields that act gently across the structure. As planets grow within them, the disks evolve with quiet precision, slowly organizing themselves into stable arrangements. The process provides a calm foundation for planetary systems, revealing the universe's ability to shape order from delicate patterns of drifting matter. The tranquil descent of solar prominences. Solar prominences are vast loops of glowing plasma that rise above the sun's surface before gradually falling back under gravity's steady pull. Their motion is smooth and deliberate, forming graceful arcs that last for hours or days. These structures glow with soft warmth, drifting through the solar atmosphere with gentle curves. Even though the sun is a turbulent environment, prominences often behave with surprising stability, maintaining their form as they move. Their slow descent reveals a peaceful side of solar activity, showing how even energetic processes can unfold with elegant calm. The silent formation of massive star rings. Some galaxies contain enormous rings of stars created when their central regions shift, or when smaller galaxies pass nearby. These rings expand in smooth, circular patterns, their stars following calm orbits that maintain the ring structure for immense periods of time. The glow of these stellar formations is gentle and uniform, spreading light across the galaxy with soft symmetry. Their creation results not from violence, but from gradual reorganization of material under gravity's steady guidance. These giant star rings represent a harmonious outcome of galactic evolution, revealing a peaceful beauty in large-scale cosmic motion. The soft unraveling of stellar streams. Stellar streams form when a small star cluster or dwarf galaxy is gradually stretched by a nearby galaxy's gravity. Rather than being torn apart abruptly, the stars drift into long, graceful trails that wrap around the host galaxy. These streams remain coherent for billions of years, moving with steady elegance as they trace arcs through space. Their presence reveals past interactions and the quiet persistence of stellar motion. They flow like cosmic ribbons, guiding astronomers to understand the history of galactic evolution. Stellar streams reflect the universe's ability to transform disruption into beauty. The gentle pulsation of variable stars. Variable stars brighten and dim in soft, rhythmic cycles caused by changes in their outer layers. This pulsation creates a calm pattern of light that repeats with reliable timing. Their brightness rises smoothly, then fades in gradual decline, forming a celestial heartbeat that can last for centuries or millennia. These stars help illuminate the distances of galaxies and the structure of the cosmos, yet their behavior remains soothing and predictable. The slow expansion and contraction of their outer layers reveal the natural balance between temperature and pressure inside stars, unfolding in peaceful intervals. The peaceful descent of planetary migration. In many star systems, planets slowly shift from their original orbits, drifting inward or outward over millions of years. This migration occurs through gentle interactions with surrounding gas or smaller bodies. The movement is gradual and balanced, allowing planets to settle into stable positions without sudden changes. These shifts shape the architecture of entire planetary systems, influencing which worlds become temperate, icy, or barren. Planetary migration demonstrates a calm process of long-term adjustment that creates order within young systems, revealing how celestial objects find harmony in their evolving environments. The quiet echoes of supernova light curves when a star explodes in a supernova. The aftermath includes a slow, graceful decline in brightness. This fading light forms a curve that unfolds with a calm, predictable rhythm. The early surge of brightness softens into a long, gentle taper as energy diffuses into surrounding space. These light curves allow scientists to understand the star's composition and the nature of its final moments. Despite the powerful event that created them, the declining glow offers a serene reminder of the star's history, spreading outward in peaceful illumination before finally dimming into silence. The soft rotation, il volo, says, stars in a galaxy's halo move in wide, slow orbits that carry them far above and below the galactic disk. Their paths are long and unhurried, shaped by the distribution of dark matter and the galaxy's overall mass. These stars are often ancient, preserving the quiet history of early cosmic evolution. They drift through space with minimal interaction, forming a gentle shell of motion around the galaxy. Their steady orbits reflect the universe's patience, revealing how structures remain stable over enormous spans of time. The gentle expansion of stellar superbubbles. Stellar superbubbles form when clusters of massive stars release energy that pushes surrounding gas outward. Despite their powerful origins, the resulting bubbles expand in smooth, spherical patterns that evolve over millions of years. Their interiors remain quiet and warm, filled with soft radiation and gently drifting particles. The outer edges mark the boundaries where warm gases meet cooler regions of the galaxy. Superbubbles demonstrate how large-scale interactions can unfold with surprising calm, forming beautiful, rounded shapes that guide future star formation. The silent cooling of quasar-light quasars are among the brightest yite objects in the universe. yet their brilliance fades slowly as they exhaust the material available to their central black holes. This dimming occurs over long intervals, creating a soft decline in energy that spreads through surrounding space. The cooling of quasar light marks a transition from intense activity to quiet stillness within the galaxy's core. As the glow softens, the environment stabilizes, allowing new structures to form in peace. This gentle fading reveals the universe's ability to shift from dynamic phases to calm equilibrium. The soft return of tidal shells around galaxies. Some galaxies display faint arcs or shells created when smaller galaxies merge into them. These tidal shells form as stars from the smaller system settle into new orbits, creating layered patterns that drift outward with time. Their motion is smooth and elegant, resembling ripples left behind on a quiet pond. These shells persist for billions of years, slowly blending into the galaxy's overall structure. Their delicate curves reveal the hidden stories of past mergers, showing how celestial interactions can produce tranquil, enduring beauty long after the original event. The calm spiral of ram pressure, stripping tails. When a galaxy moves through hot intergalactic gas, its own gas can be gently drawn out into long, trailing structures. These ram pressure tails flow behind the galaxy like soft streams drifting in spots. Their shapes are smooth and elongated, evolving gradually as the galaxy continues its journey. These tails sometimes glow faintly, illuminated by young stars that form within them. The process unfolds over long time scales, creating tranquil patterns that trace the galaxy's path through its environment. Ram pressure strips reveal how galaxies interact with surrounding gas through quiet, steady motion. The gentle circulation of galactic warp waves. Some galaxies, including the Milky Way, display soft warps in their disks, subtle bends that ripple through their outer regions. These warps arise from the calm pull of nearby galaxies, the motion of dark matter, or the steady flow of intergalactic gas. The waves move slowly across the disk, shifting stars and gas in graceful arcs that evolve over millions of years. This gentle distortion adds a quiet flowing motion to the galaxy's overall structure, creating an impression of a cosmic sheet drifting in a light breeze. Galactic warp waves reflect the delicate interplay between internal rotation and distant gravitational influences, revealing how galaxies settle into balanced shapes through patient, fluid movement. The soft harmony of multi-moon resonances. In some planetary systems, groups of moons share stable resonances, moving in coordinated orbits that remain synchronized over immense periods. Each moon adjusts its path slightly in response to the others, creating a balanced pattern that prevents collisions and maintains long-term stability. Their dance is slow and measured, shaped by gravity's consistent pull. These resonant systems demonstrate how celestial bodies can form natural harmonies without direct contact, drifting side by side in quiet companionship. Their orbits echo a peaceful rhythm, offering a serene example of order emerging from the subtle interactions of multiple worlds circling a shared host. The tranquil halos of faint dwarf galaxies. Faint dwarf galaxies contain only a small number of stars, distributing them across large, delicate regions. Their light is soft and subdued, forming quiet halos that blend gently into surrounding darkness. These galaxies rotate slowly, lacking the strong stellar winds and intense energy found in larger systems. Their simplicity offers a peaceful portrait of galactic structure, free from turbulence or dramatic motion. Despite their size, these dwarfs play an important role in cosmic evolution, gradually contributing stars and gas to larger galaxies. Their presence represents the quiet foundation upon which more complex systems are built. The silent descent of dust through molecular clouds. Within molecular clouds, dust grains drift downward under the faint pull of gravity. Their motion is extremely slow, shaped by density, temperature, and the gentle influence of nearby stars. This descent helps concentrate material in the cloud's core, preparing regions for star formation. The drifting particles absorb starlight and scatter it softly, creating dim glows that reveal the cloud structure. Their movement resembles a cosmic snowfall, unfolding in complete silence across vast distances. Dust settling in molecular clouds highlights the universe's ability to shape creation through calm, nearly basal, imperceptible steps. The soft unfolding of stellar ejection nebulae. Sometimes, stars release material in quiet bursts that expand outward to form diffuse nebula. These ejections occur when a star shifts in temperature or internal pressure, sending layers of gas drifting into space. The resulting nebula forms gentle shapes that evolve slowly as the material cools and spreads. Starlight illuminates these structures with soft colors, bringing faint blues, reds, and purples to otherwise dark regions of the sky. Though linked to internal stellar processes, the expansion itself remains smooth and unhurried. These nebulae reveal how stars reshape their surroundings with delicate, graceful motions. The gentle lift of star-forming outflows. In some young stellar systems, outflows of gas rise from forming stars in narrow, soft jets. These streams are slow compared to many cosmic events, moving with measured steadiness as they clear pathways around the emerging star. They help regulate the star's growth, preventing excess material from spiraling inward too quickly. The outflows shine faintly when struck by surrounding radiation, creating peaceful beams that drift through molecular clouds. Their presence marks a calm stage in stellar development, revealing how stars find balance through gentle release as they grow. The peaceful weaving of intergalactic bridges. When two galaxies pass near one another, streams of stars and gas may stretch between them, forming delicate intergalactic bridges. These structures grow over millions of years, shaped by smooth gravitational tides. The bridges glow faintly with the combined light of individual stars, appearing like soft threads binding two cosmic islands. Their formation occurs without violent collisions, relying instead on gradual distortion and quiet exchange of material. Intergalactic bridges highlight the universe's subtle connectivity, revealing how distant systems can influence one another through calm, elegant motion. The silent gathering of giant molecular filaments. Giant molecular filaments are long, thread-like clouds of gas and dust that stretch across hundreds of light years. Their formation results from the slow alignment of material along magnetic fields and gravitational lines. These filaments serve as nurseries for star formation, guiding gas into dense pockets where new stars ignite. Despite their size, they evolve quietly, drifting with interstellar currents while maintaining coherent shapes. Their presence offers a serene portrait of cosmic structure, showing how vast formations can arise through soft, coordinated flow rather than abrupt events. The soft flow of ionized gas in H2 regions. H2 regions are glowing clouds of ionized hydrogen created by the light of young stars. Their gas expands gently outward, forming smooth gradients of temperature and color. The motion within these regions is calm, guided by the balance between stellar radiation and gravity. Over time, the gas cools and recombines, settling into new patterns that support future star formation. The soft glow of H2 regions reveals the universe's peaceful approach to creating fertile environments where stars and planets can develop. Their slow, luminous flow adds tranquility to the process of cosmic renewal. The gentle cooling of supermassive Hata halos around many galaxies, especially large ellipticals. Vast halos of hot gas extend far beyond the visible stars. This gas cools extremely slowly, radiating energy at a calm, steady pace. As it loses heat, it drifts inward in delicate currents, eventually contributing to new star-forming regions. The halo's gentle glow forms a soft backdrop to the galaxy's brighter core, creating a layered structure that evolves over billions of years. These halos demonstrate how even energetic environments can maintain serene, controlled behavior, shaping cosmic evolution with patient precision. The tranquil turn of hypervelocity. Stars. Hypervelocity stars are rare stars that travel through space at extraordinary speeds, yet their motion remains smooth and uninterrupted. They move along long, open trajectories shaped by past encounters with black holes or dense stellar regions. Despite their velocity, their journey feels calm as they drift through the galaxy with no resistance. Their movement symbolizes escape and independence, reflecting a peaceful detachment from their original environments. Hypervelocity stars remind us that even rapid motion can exist within the universe's quietest spaces, where nothing disturbs a star's solitary flight. The peaceful rise of extended stellar halos. Some galaxies form enormous halos of stars that stretch far beyond their visible boundaries. These halos develop gradually through the quiet accumulation of ancient stars, remnants of mergers, and small galaxies absorbed over time. The stars drift in wide, gentle orbits, creating a diffuse glow that surrounds the galaxy like a soft aura. This extended structure evolves slowly, maintaining stability across billions of years. Extended stellar halos highlight the universe's ability to assemble vast, delicate layers through calm and continuous motion. The silent coalescence of young star chains. In some regions, stars form in elongated chains that drift together through space as unified structures. These chains arise within dense molecular filaments, where gravity encourages stars to align along narrow pathways. Their motion is slow and coordinated, shaped by the gentle pull of surrounding material. Over time, the chains may merge into clusters or dissolve into the galaxy's broader stellar field. Their formation offers a peaceful view of how stars organize themselves in the earliest stages of their lives, reflecting the universe's natural inclination towards soft, linear patterns. The soft balance of galaxy cluster cores. The centers of galaxy clusters contain dense concentrations of galaxies, hot gas, and dark matter. Despite this density, the core often maintains a balanced, tranquil structure, with material circulating in slow, organized flows. Cooling gas settles gently toward the center, while galaxies drift through in wide arcs. The equilibrium within these cores highlights the universe's ability to maintain order even in crowded environments. Their quiet dynamics create a stable foundation for the cluster's long-term evolution. The gentle drift of fossil galaxy streams. Some galaxies carry ancient streams of stars that remain from long-forgotten mergers. These fossil streams drift quietly through the outer halo, forming delicate arcs and soft trails that slowly fade over billions of years. Their motion is calm and unhurried, shaped by the gentle pull of the galaxy's gravitational field. Each star within the stream follows a wide, looping orbit, preserving the memory of the smaller galaxy it once belonged to. These fossil structures represent the universe's long-term recording system, maintaining elegant traces of past interactions without turbulence or disruption. As the streams gradually disperse, they blend into the background halo, becoming part of the galaxy's serene outer glow. The soft glow of warm, hot intergalactic medium between clusters and galaxies lies a faint, nearly invisible component of the cosmos known as the warm, hot intergalactic medium. This vast reservoir of diffuse gas spans enormous distances, glowing subtly at high temperatures. Its presence can only be detected through soft signatures in the light of distant objects. The gas flows slowly along gravitational pathways, forming smooth bridges between large structures. Its movement is gentle, shaped by the quiet expansion of the universe. This medium represents one of the calmest environments in existence, supporting the cosmic web without producing sound, shock, or turbulence. The peaceful alignment of magnetized outflows. Some galaxies produce long, magnetized outflows that extend far beyond their disks. These outflows move in graceful, narrow columns shaped by magnetic fields and slow, steady winds. Their structure remains remarkably ordered, revealing parallel strands that drift with quiet precision. Over time, the gas cools and spreads outward, forming soft gradients across intergalactic space. The alignment of these outflows demonstrates how magnetic fields guide matter into peaceful, organized motion. Their long, slender forms add a gentle vertical elegance to galactic environments. The silent cooling of fossil galaxy groups. Fossil galaxy groups are systems where a single large galaxy dominates a region once filled with many. Over billions of years, these groups settle into calm equilibrium, with hot gas cooling slowly in the background. The surrounding galaxies drift outward or merge into the central one, leaving a quiet, stable environment. The cooled gas emits soft X-ray light, forming a dim halo around the dominant galaxy. Despite their dramatic histories, fossil groups now exist in peaceful isolation, offering serene examples of cosmic maturity. The soft formation of stellar shell galaxies. Stellar shell galaxies contain faint, layered arcs of stars that ripple outward like the rings of a gentle cosmic tide. These shells appear when smaller galaxies merge into larger ones, but the resulting patterns evolve quietly rather than chaotically. The stars move in slow, predictable loops that create elliptical layers around the host galaxy. Over time, the shells drift outward and fade, blending seamlessly into the surrounding halo. Their formation demonstrates the universe's ability to the calm circulation of hot bubble structures. In some galaxies, pockets of hot gas form smooth bubbles that rise through the surrounding medium. These bubbles expand gently, carried by differences in temperature and pressure rather than sudden force. Their interiors remain stable, filled with soft radiation that drifts outward over time. As they rise, the bubbles carve quiet pathways through the gas, shaping large-scale structure with delicate precision. Their motion resembles a slow dance within the galaxy, revealing the tranquil balance between heat, pressure, and gravity. The gentle flow of photoevaporation streams in star-forming regions. Intense light from young stars delicately pushes away surrounding gas, creating soft streams of material that drift outward. This process, known as photoevaporation, unfolds slowly, shaping the edges of dense clouds with smooth curves. The streams glow faintly as ultraviolet light interacts with the drifting gas. Over long time scales, the process clears pathways for new stars to emerge, sculpting their environments with quiet radiance. Photoevaporation shows how light can guide matter in peaceful, continuous motion. The silent spread of extended cosmic dust halos. Around many galaxies, faint halos of cosmic dust extend far beyond the visible disk. These halos are composed of tiny grains that drift outward through slow winds and gentle gravitational disturbance. Their distribution forms a soft haze that filters starlight, giving the outer regions a muted, tranquil glow. The dust settles into stable patterns, evolving gradually as new grains join and older ones disperse. These halos represent the quiet, unseen layers of galactic ecosystems, adding subtle depth to their structure. The soft breathing of galaxy cluster gas. Waves galaxy clusters contain enormous reservoirs of hot gas that move in smooth, wave-like patterns. These waves travel slowly through the cluster, formed by subtle changes in pressure or gentle gravitational interactions. The motion is calm and rhythmic, spreading energy evenly across vast distances. Over time, the waves help keep the gas in equilibrium, distributing heat without violent turbulence. Their slow propagation resembles a quiet breath taken by the cluster, reflecting the natural stability of structures on such grand scales. The peaceful curves of weak lensing patterns Weak gravitational lensing occurs when massive structures subtly distort the light of distant galaxies. These distortions form gentle curves and stretching patterns that reveal hidden matter across the universe. The effect is soft and nearly imperceptible, requiring careful observation to detect. Yet the patterns show how gravity shapes space with quiet precision, altering the paths of photons without force or disruption. Weak lensing acts as a delicate imprint of the cosmic web, tracing its structure through graceful shifts in light. The silent assembly of large quiescent galaxies. Quiescent galaxies are massive systems where star formation has ceased, leaving behind calm populations of ancient stars. These galaxies grow slowly through the gentle merging of smaller companions. Their stellar motions settle into smooth, elliptical patterns without spiral arms or chaotic bursts. The light they emit is soft and even, creating a warm, stable glow that persists for billions of years. Quiescent galaxies represent a serene stage of galactic evolution, where change occurs through subtle shifts rather than active creation. The gentle dissolution of globular clusters. Globular clusters are dense spheres of stars that orbit galaxies in wide, slow paths. Over time, gravitational forces cause some stars to drift away, forming faint tails that spread into surrounding space. This dissolution unfolds quietly, with stars leaving the cluster in soft trickles rather than sudden bursts. The remaining core remains stable, its stars moving in smooth orbits that preserve the cluster's spherical shape. The gradual fading of globular clusters reflects the calm passage of time on cosmic scales. The soft rotation of circumgalactic gas rings. Some galaxies are surrounded by vast rings of cool gas that rotate in wide, slow circles. These circumgalactic rings form when gas settles into stable orbits beyond the main disk. Their motion is serene, unhurried by turbulence or external pressure. Over long periods, they supply galaxies with fresh material for star formation, drifting inward in gentle streams. The ring's symmetry and softness create a peaceful outer layer that supports the long-term evolution of galaxies. The tranquil descent of minor mergers. Minor mergers occur when small galaxies slowly blend into larger ones. The process unfolds over hundreds of millions of years, with the smaller galaxy gradually losing its identity as its stars join new orbits. This transition is smooth, guided by gravity's steady pull, rather than violent collisions. The resulting structures appear as soft stream or faint shells around the host. Minor mergers illustrate how galaxies grow through calm integration rather than disruption, preserving stability across enormous scales. the silent weave of interstellar filament networks. Within molecular clouds, thin filaments form intricate networks of gas and dust. These filaments connect like quiet pathways, guiding material into dense nodes where stars are born. Their structure arises from the gentle balance of gravity, turbulence, and magnetic fields, creating long, soft threads that drift through interstellar space. Over time, the network evolves as filaments merge, stretch, or dissolve, shaping the birthplaces of future stars. Their delicate geometry reveals the universe's preference for organized, harmonious forms, even in its darkest regions. The gentle cooling of ancient stellar remnants. Across the galaxy, countless ancient stellar remnants continue to cool in deep silence. These faint objects, long past the bright stages of their evolution, radiate the last traces of heat into the darkness around them. Their glow fades slowly, in nearly imperceptible increments, shaping a timeline that stretches across billions of years. Each remnant follows a predictable path toward deeper stillness, settling into equilibrium with the cold vacuum of space. Their existence is serene, free from the storms and eruptions that once defined their earlier lives. These remnants drift through the galaxy like dim embers, carrying with them the soft memory of the stars they once were. Their quiet transformation reflects the final, peaceful stage of stellar existence, revealing how the universe guides even its brightest objects into calm, enduring rest. The soft sculpting of low-surface brightness galaxies. Low-surface brightness galaxies spread their stars thinly across vast regions, creating delicate patterns that barely rise above the darkness of space. Their shapes form slowly, guided by gentle gravitational forces that organize their diffuse material into broad, faint structures. These galaxies evolve without intense bursts of star formation, preserving a calm, stable appearance over long stretches of time. Their stars move in wide, tranquil orbits that maintain the galaxy's shape without turbulence or crowding. Though faint, they reveal a softer side of cosmic architecture, where structure emerges through patience rather than pressure. Their existence highlights the universe's ability to craft quiet, understated beauty on grand scales, offering peaceful reminders of the diversity found in galactic forms. The tranquil interplay of ancient dark matter streams. Dark matter streams drift quietly through galaxies, forming soft, unseen currents that influence the motion of stars. These streams are relics of long-ago mergers and interactions, carrying a subtle gravitational imprint of the universe's early history. Their flow is smooth and continuous, shaping the orbits of stars without producing light or sound. Over time, dark matter streams gradually blend with their surroundings, becoming part of the galaxy's broader gravitational field. Their presence adds hidden structure to the cosmos, guiding celestial motion with gentle persistence. Though they cannot be directly observed, their effects reveal patterns that echo through the galaxy's behavior. These streams show how the universe maintains stability through invisible, calm forces that work quietly across unimaginable distances. The silent coherence of interacting galaxy pairs. When two galaxies move near each other, they often form stable, long-lasting pairs that drift through space with gentle coordination. Their mutual gravity creates slow, coherent motion that keeps them bound together without forcing a collision. Over millions of years, faint bridges of stars and gas may stretch between them, forming soft connections that evolve gradually. Each galaxy influences the other's rotation and shape, creating balanced patterns that remain steady across vast timescales. Their shared journey reflects a peaceful companionship, showing how even enormous structures can exist in quiet partnership. Interacting galaxy pairs highlight the universe's ability to create harmony through the subtle pull of gravitational attraction. The gentle rise of faint halo substructures. Around many galaxies, faint substructures drift through the outer halo like soft echoes of earlier events. These substructures consist of old stars, diffuse gas, and streams formed by past mergers. Their motion is unhurried, shaped by the galaxy's extended gravitational field. Over time, they form delicate arcs and subtle gradients that slowly blend into the surrounding environment. Their presence reveals the quiet layering of galactic history, where ancient events leave graceful imprints that persist long after their origins fade. These faint features add depth to the galaxy's outer regions, offering tranquil hints of how cosmic structures evolve with patience and continuity. The soft descent of cooling flow, gas in clusters. In some galaxy clusters, hot gas slowly cools and drifts inward toward the central galaxy in a process known as a cooling flow. This descent unfolds at an unhurried pace, forming smooth streams of gas that settle gently into deeper regions of the cluster. The cooling material contributes to soft X-ray emissions that radiate with quiet consistency. As the gas settles, it creates conditions that may eventually support new star formation, although the process remains slow and balanced. Cooling flows demonstrate how energy dissipates through calm, controlled pathways on cosmic scales, shaping cluster evolution through gradual transitions rather than sudden change. The tranquil persistence of stellar fountains. Stellar fountains occur when regions of active star formation gently push gas upward into the galaxy's halo. Over time, this gas cools and drifts back down, forming a peaceful circulation loop. The motion is smooth and continuous, carrying enriched material into higher regions before returning it to the disk below. These fountains contribute to the long-term balance of a galaxy's ecosystem, redistributing elements without creating turbulence. Their presence reveals how stars and gas participate in quiet, regenerative cycles that sustain galactic life across billions of years. Stellar fountains embody the universe's natural rhythm of release and return, the soft migration of slowly drifting star chains. In some regions, elongated chains of stars move together through space with gentle coordination. These chains often form within filaments of molecular clouds, where stars emerge along narrow pathways before drifting outward in unison. Their motion remains aligned for millions of years, guided by the gravitational memory of their shared birthplace. Over time, they may disperse into the broader field of the galaxy, but their early alignment persists as a quiet signature of their origin. These drifting chains show how stars can carry the imprint of their birth environments long after they leave them, offering a peaceful example of continuity across cosmic distances. The peaceful diffusion of galactic metal enrichment. As stars age and release elements into space, these materials gradually diffuse into their surroundings through soft, slow currents. Over immense timescales, these elements blend with nearby gas, contributing to the chemical richness needed for new stars and planets. The process unfolds quietly, without shock or disruption, forming smooth gradients across a galaxy's disk and halo. This enrichment shapes the long-term evolution of galaxies in subtle ways, supporting cycles of formation and renewal. The diffusion of elements shows how the universe recycles material through gentle, persistent motion, creating harmony between old stars and new generations. The silent merging of the universe's faintest structures, the smallest cosmic structures, tiny dwarf galaxies, sparse star clusters, and isolated streams, often drift toward larger systems and merge with them in absolute quiet. These mergers occur over hundreds of millions of years, allowing the smaller structure to dissolve gently into its host. Stars settle into new orbits, gas drifts into stable patterns, and the overall shape of the galaxy adjusts with smooth precision. The process leaves behind faint signatures, subtle shells, delicate streams, or soft changes in brightness. These mergers complete the universe's story of growth through calm integration, showing how even the faintest structures contribute to the grand, peaceful evolution of the cosmos.